The question we are solving now belongs to test series 2. It is a control system subject. In specific, it belongs to Nyquist analysis of control system. As per the question, the open loop transfer function of a unity negative feedback control system is given as g of s multiplied by h of s is equal to k by s into s plus 1 into 2s plus 1 into 3s plus 1. We need to find the Nyquist plot of the control system. So for the given control system, we see that upon substituting s is equal to j omega, g of j omega multiplied by h of j omega is equal to k by j omega into 1 plus j omega multiplied by 1 plus 2j omega multiplied by 1 plus 3j omega. So from this we can write that magnitude of g of j omega h of j omega is equal to k by omega into square root of 1 plus omega square root of 1 plus 4 omega square multiplied by square root of 1 plus 9 omega square. Also, phase of g of j omega h of j omega is equal to minus pi by 2 minus tan inverse omega minus tan inverse 2 omega minus tan inverse 3 omega. Please note that here the phase of minus pi by 2 corresponds to j omega term, phase of minus tan inverse omega corresponds to 1 plus j omega term, and phase of minus tan inverse 2 omega corresponds to 1 plus 2 j omega, and minus tan inverse 3 omega corresponds to 1 plus 3 j omega. Similarly, the magnitude of g of j omega h of j omega is also obtained. So upon finding g of j omega at omega equal to 0 plus, we see that g of j omega h of j omega is equal to infinity. This is because of the reason that the magnitude of g of j omega h of j omega at omega equal to 0 plus is infinity, and the phase is minus pi by 2. Similarly, as omega tends to infinity plus, g of j omega h of j omega can be written as 0 at a phase of minus 360 degrees, because at omega equal to infinity plus, the magnitude is 0 and the phase is minus 360 degrees. From this, we can plot the Nyquist plot of the control system. Also, please note that from the given g of j omega h of j omega, we can say that g of j omega h of j omega is equal to minus kj multiplied by 1 minus j omega. This is by rationalizing g of j omega h of j omega as such, multiplied by 1 minus 2j omega multiplied by 1 minus 3j omega divided by omega into 1 plus omega square 1 plus 4 omega square multiplied by 1 plus 9 omega square. From this we can see that the real part and imaginary part become 0 at omega is not equal to 0. Hence we can say that from omega equal to 0 plus to infinity, the Nyquist plot of the control system intersects the real axis and imaginary axis. So from this we can plot the Nyquist plot of the control system as shown. This is from omega equal to 0 plus to omega equal to infinity plus. So due to the symmetry, the Nyquist plot of the control system can be plotted as shown from omega equal to infinity minus to omega equal to 0 minus. Also, due to the s term, the Nyquist plot makes an angle of minus phi in counterclockwise direction, that is pi in clockwise direction. This is from omega equal to 0 minus to 0 plus. So from this we can say that the Nyquist plot of the control system can be obtained as shown in the figure, Hence, the correct option representing the Nyquist plot of the control system is A.